Welcome to the world of Subnautica, an underwater survival horror game where you play as Riley Robinson, our original, who has to find a way off this planet. That's basically like a whole summary of the game. At first, everything seems alright. Your new neighbors seem friendly, for the most part anyways. The plant life looks amazing, and you seem to be doing alright for yourself. But good things never last. As you begin to explore more of this alien planet, you start to notice something's wrong here. You notice there's something strange about the fauna life. Some of them have green spores growing on them. It's almost like they've been infected with something. Introducing the Kara. I think that's how you pronounce it, I'm not sure. The Kara is an alien bacterium discovered by the architects during the exploration of an unknown planet. Unfortunately, I'm not talking about the story or the game mechanics. I'm only going to be focusing on the Kara. Specifically, its chemical reaction and its chemical equation. So let's dive right in. You see what I did there? First things first, I think we need to start off by figuring out what the Kara actually is and what it actually does. So let's do some research. After looking online and reading through the game's PDA files, you can find a lot about the Kara. Something that we know right off the bat about the Kara is that it's a waterborne bacterium, as stated by the PDA, quote unquote.
Self-scan complete. Bacterial infection has spread to the skin and pulmonary system. Medical report recorded to data bank. It is imperative you find a way to neutralize the infection.
So the Kara is a waterborne bacterium and it works fast. Let's see what else we can find. Reading through the PDA files some more, we find out about the bacteria's mechanisms, symptoms, and displaying signs of bacterial infection. The Kara, quote unquote, attaches to healthy living cells and mutates to a basic genetic structure. Okay, so now we know how it functions. What about the symptoms? The symptoms of Kara include 4 stages. Stage 1, none. Stage 2, gradual immune system failure. Stage 3, unpredictable alterations to biological structure. Stage 4, complete shutdown of executive function. Great, now what about the displaying signs? This organism is displaying signs of a bacterial infection. Bright green blisters are forming networks around the infection sites. Pathology suggests a waterborne bacterium capable of penetrating the body through the skin and respiratory system, underlying indications of genetic mutation and aggressive behavior. The bacterium itself is unlike any so far recorded in human exploration. Appearance-wise, the Kara manifests itself in bright green cysts along with similar colored veins that spread throughout its host. The cysts start off as small protrusions. As time goes on, they start to grow bigger and glow more intensely. Great. Now that we have all this information, it's time to move on to the next step. Based on the information we know about the Kara and how it functions, it'll have these following byproducts. Probably. Number 1. Carbon dioxide, generated as a byproduct of metabolic processes within the bacterium. Number 2. Toxins. Depending on specific mechanisms of pathogenesis, toxins produced by the Kara can be considered byproducts of its activity. These toxins may contribute to skin irritation, which is something that we have, and other symptoms described by the game. Number 3. Bioluminescence. We know that infected organisms have bright green cysts all over the bodies that glow, and although this is probably a cosmetic thing, it could actually have some function. Typically, bioluminescence is used to warn or invade predators, to lure or detect prey, and for communication between members of the same species. But in the case of Subnautica, Kara's bioluminescence is most likely used to attract predators of its host, to heat them up so the Kara can transfer to a new host and spread. Number 4. Organic acids. As a result of metabolic pathways of its reactions with host cells, Kara may produce organic acids as metabolic byproducts. Number 5. Mutagenic compounds. If the bacterium induces mutations in host DNA as part of its pathogenesis, the compounds involved in this process could be considered byproducts. Now that we've listed our options, it's time to pick one for further investigation. Since I can't really ask anyone which I should pick, I'll just pick one myself. Can you guys guess which one I picked? If you said bioluminescence, you're right! Moving on now. It's finally time to talk about our chemical reaction and our chemical equation. First, we have our bioluminescence reaction. Oxygen reacts with substances called luciferin, producing energy in the form of light. Next, we have our chemical equation, and here it is. In this equation, luciferin represents the organic substrate. Oxygen serves as the electron acceptor, and oxyluciferin is the oxidized form of the substrate. Water is a byproduct of the reaction, and light is emitted as a result of the excess energy released during the oxidation process. And that's it. We found our equation. Well, one of them anyway. I hope y'all enjoyed this little analysis video. And if you're wondering about the other options, then I encourage you to do your own research and use what you learned from this video. If you learned anything from this video. I hope you did, at least.